Oh, well, thank you very much for attending. I'm going to go for some slides introducing R. Then I've got some demonstration. I'm going to show you where you can find our outstanding tutorial to do more work and use it as a references. And as well, we'll have some questions. So when I say question time, all the questions in the chat, you can fire them up, and then Alex will kindly group your question and ask if you have any. Okay, that would be great. Thank you. Right, so we can make a start. Thank you very much. Okay, so why learn R? R, it's there's a lot of good reason to learn R. It's cross-platform compatible. It's advanced statistical language, and they got loads of libraries for what R doesn't provide, such as DataSHIELD. It's got some outstanding graph. It's flexible and fun, and as well, it's a language that's always evolving, which is a good thing. So we're going to introduce R to our programming, but as well, the demonstrations is going to be more focused on what you can do from a statistical background, because I am assuming you already have used packages such as MATLAB or SPSS, or are very good at using statistics. So what did we know? That R is already more than 25 years old. It's been created in 1993, and it's called R because it was from a Ross and a Robert that created it. It contains a lot of basics and advanced statistical and graphical tools, and it is used in academia and the industry. Well, Microsoft, I think, is using it as a basic skills nowadays for when people want to go and work with them. I was quite surprised last time I had a look there. Our programming language is currently developed as an open source. That means it is free to use, and you can develop your own library. And you've got something called Comprehensive Archive, our archive network, which is basically libraries, and our user can develop and improve R, can be included there, and they are managed by a small team actually who do that. R provide a range of packages and library developed in R, but as well C, C++, Java, and Python. So it's quite a very flexible language, and that is why it is used quite a lot. Okay, now the naming of R, they always got really fun names, and the current one is 4.03, and it's called Bunny Bunny's Freak Out, and it's based on that cartoon. I don't know why basically they do that for each version of R, but that's what they use, and it's quite fun. So there you go. The current version is 4.03, and often with packages, because the versions quite to change every seasons as well, it's worth noting if you do your own package, you need to keep up with the packages so that it's compatible. Now, R is a programming languages. For some of you, you may be thinking, well, I do statistics. Why do I need to use a programming languages? Well, I think these two worlds have been merged together. And what we have, we've got some data types, some logical, that's true or false. It's called Boolean in other languages. You've got some numeric, you've got some integer, some complex, and as well some characters. Characters are mainly for names, a string of a character A, B, and C, and all that, and they're between quotes. Okay, something you need to bear in mind. I'm going to use the word variable when I'm talking about program variables or script variables, and they're not the same as statistics one. So I'm going to use the word statistical variable instead when I'm mentioning the statistic notion of variables. You have as well some data structures, vectors, list, matrices, array, factors, data frame, tables, and now data table. I will show you where you can learn all about them in our tutorial, but they're quite good. They're very good to manipulate and group information together. You've got some arithmetical operators, the normal one, the modulus and the exponent. You've got some logical operators. These operators, we use them for comparison. So we've got the equal, the greater than equal, and not, and, or. We've got as well some selection, that's called the if statements, and loops as programming construct. Now, in a green box, you can see that it's mentioned that R is a functional language, and everything, it's a function. Everything is more or less a function. So often what we do, we use many computations are completed by using a function or calling a function. So if you are watching this video or already done some programming in another language like C, Java, Python, and many others, often we use loops to navigate through matrices, arrays, and factors, and all this aspect. Here we do not. So that's when we come back to that. So a lot of things will be functions, and you will see how one function can extract data from around the world later on. Right, a quick comparison against spreadsheets, against R, because often we may have all used spreadsheet, of seen, or be aware what they do. So it was to compare them. So spreadsheets, they use tables like R, but R use more data structured. We've looked at it early on, they've been mentioned. We separate data and programs. Well, in spreadsheets, we do not, but in R, we do. And that's quite an important element. Spreadsheets bring no end of issue in data science. And often things we have done or computation we have completed in spreadsheets need to be implemented differently in R. So data go in one data source and the computation goes somewhere else in R. We've got some graphic representation tools. They both present in spreadsheets and R. We've got some statistical tool available in spreadsheets, but some of them could be quite basic, but you can add libraries or purchase them often. In R, you've got some more advanced tool, and more can be provided, and there's so many libraries that provide loads more. It's quite a better tool. I would believe MATLAB and SPSS would be the same there, but they may be costly. Okay, so we share data, that is true. So with R, data can be cleaned, mined, merged, analyzed using some well-developed tools. Having said that, spreadsheets, they're not guaranteed to do the same from one spreadsheet to another one. So it's a bit more tricky with that. There is a graphical user interface in spreadsheets. In R, we use an IDE, integrated development environment. Otherwise, we use some command line interfaces. Now, there is a new tool which is called RShiny, where you can, on your model, create some graphical user interface on your own if you want to share a model that you use with different elements. But we'll have a look at the IDE later on and how we can use as well notebooks. The cost, well, some spreadsheets are free, some are not, especially the Microsoft one. But R is free, it's an open source project, and you can contribute to it. So some tips for programmers, or if you're completely new to it, I should say. So you've got data structure manipulations, and often loops are much slower. Instead, we tend to use, in other languages, it would call lambdas, and that's why we would use, it got similar element, which based on function codes. We write clear code that should be for anywhere. Name variables clearly, we structure the code so that it's easy to read, and we comment the code so that other can understand your chain of thought. But I'm sure everybody does that for what they're doing. Another thing about standard, there is a lot of people would recommend how to name your variables. Having said that, some organizations have other naming. So consistency is the best way. And as long as people can see the name of your variable and code and understand them without too many difficulties, you've done well. And remember about standard, the good thing about standard is there are so many to choose from. As long as you're consistent from one piece of work, you will be fine. And as well, talk to your team. I'm going to show you a demonstrations and as well where to find the link to the tutorials at the end of this workshop. And you will see, you will have some beginners. So some people may be new to R and programming. So you will be taught some basic R, the programming concept, but this workshop will complement that by showing you what you can do statistically, okay? You will have some section which are not quite advanced. You may new to R, but have some programming knowledge and you want to dive in and learn a bit more. And if you already know so in-depth programming languages or know already a bit of R and you want to deepen your understanding, look for the advanced sections. In the sections of this tutorial, you will find some information related to R so that you can use DataSHIELD, which will be introduced the next workshop by Alex and Dimitris. You will have as well some additional reading list because we cannot put everything in one tutorial. So I've checked all the reading lists are still appropriate and I've added some new one and added more content actually. And you'll have some practical activities where you can write your R code and have fun with it and learn very quickly. And you have access to some other tutorial to develop further your elements. So if there is anything missing, please contact me, contact the DataSHIELD team, and Elaine will kindly forward that to me and I will do my best to provide them. Okay. Now, the online resources, they've been designed to be completed by distance over a period of time. So use it, share it, reference it, and use it as a references. Okay. So a quick review. So that's basically, you should be sharing now RStudio. Is that correct, Alex and Elaine?
Yes, I can see that.
Brilliant, thank you. I'm keeping it that way for the time being to show you how it looks like, and then we will look at a demonstration. So here you are, here you've got a console where I can type some comments there. So if I want to have a look, I want an LS, which will show all the variable I've got there. They will show me all the name of my variable I've got already created for my previous work there, and if I want to find some comment thinking, what does it mean, this ls, I put a question mark first and I put ls, and then you can see the help object open straight away. So often you have a description, some usage with a lot of these arguments and the default values. And often, what is great, you have some example at the bottom there, and you can just copy and paste them to see what they happen. So I'm going to copy that one there and see what happened. And I copy in my console and see what, and then I can see what this example does, and then I can learn quicker and see what happened. Of course, I would expect people to retype them, but sometimes we don't have time. So just to learn what is happening, you can do that and work them behind. You have as well, you can get access to your files from your project. If you have some plot graphs, they will be shown here. You can have a look at the packages that they are uploaded, and if you click them, you upload them. If you unclick them, they're not being used. You've got as well your help, where you can see, and then you've got as well some viewers, some other informations. You have as well, a bit like MATLAB and I believe SPSS, I know very little there. You have what they call a global environment. The global environment, it's where all the variables by default are kept. And it's always have the position 1. So if you see pos equal 1 later on, we know we're working in that environment. So you can have a look at the values. You can have a look the way they look like. They're great for a quick exploration. They may not have been as well developed as MATLAB or SPSS thought, but there you go, that's what we work with. Okay, can have a history as well of all your operation you've done and some connection if you connect to some databases. So there you go. But I want to clear what I've got there, and I've got all my variables have been clear. Now you've got what we call as well what they call a source, and that's where you put some script. If you want to create a new script, you click on the plus sign and you've got our script. I'm going to create one which become like an empty shelf, and I'm going to write a print hello world. That's what we always do, don't we? And if I want to run it, I just run the line by click and run, or if I want to do, or I can click source and every line will be shown and it shows the word source hello world. So that's basically the way a script does. But now what I'm going to show you, it is a notebook, and I don't want to save it. Silly me. Right, don't save. There you go. What we call as well our notebook, which allow us to use more some contextual content as well as some R command, and then we have our lovely reports out of that. Okay, so I've created an R notebook for this demonstration of what can be done with it in a such way that you can see the command, and as well you can see the results, and we can explore. So can somebody tell me whether or not you can see clearly the screen and the code? Alex, please.
I can, just in case everyone else can.
Yeah, if somebody cannot see it, it's time to speak up, and I'll put the font even bigger for you. That's my pet hate when I'm in meetings. Always ask that, so ask everybody else. Probably only my eyes, they just need some element. So I've decided to indulge to working with large data in this workshop to show what can be done. And I've used the COVID-19. COVID-19 got at least a plus. We've got loads of data, tons of data. And we're going to work with 1 million. So millions of rows and data. So some element may take a little while just to show you what is happening. But what's happening with this additional package called COVID-19, which is free and you can install it yourself. It's connect from around the world, what we call a data hub. And if you click COVID-19 datahub.io, they explain to you where all the data comes from and how it's been done and all that. So please have a look, it's quite interesting. So, but it shows the power of R, and that's what I really like. Okay, so here I'm going to be having what they call a notebook, and we have a lot of instructions called in our Markdown. In our tutorial, you have added some information how to format them. It's quite easy once you get used to it, and you will got there. Now, what I'm going to show you, it is just a demonstration how to use R with large data set. The COVID-19 package is only used for this aim and for no epidemiological purposes, please. Okay, I'm not trying to demonstrate what's happening with COVID-19. I just want to do some statistics and show you with large data set. Okay, so when we want to install packages, we need to type install packages and COVID-19, and that line basically will magically connect through the internet and using through the internet and install the COVID-19 packages onto your device, and you can do that. I put in as a comment there, that little character that it's comment, it appears in green, because I don't need to install it. Okay. Now, when I want to use a library, I've shown you before this list of packages where I can tick them. By ticking them, it calls a function called library, and this library, what it does, it makes it available all the functions and COVID-19 offers. And that one, it's so small, it's only one function called COVID-19. That's quite cool. Now I've got as well, I come back to that, the source. I've got some other code stored in r/tools folders, and I want to make it available within my script or within my my console or within my notebook. So what I've done, I've written source, and when by doing the word source, all the code of that R file is being executed. So if I had put some errors, which I did when I wrote it first, nothing would run further that command, and everything would go badly. So hopefully, if I click on my green arrow, the code should be executing now, as you can see, and something happened. Now, you will have something in red, and red always think to me with danger. Although I quite like red, but don't be alarmed by that, because it's just a warning, and it's just telling us, and I'm using the latest version of it, of R, and that package has been built under the R version 4.03. So if the package is fortunately working, but if it would have some issues with it from one version to another one, then I would need to explore and test, making sure it's working appropriately. So first, we import the data, and using the COVID-19 data, it's just a function call. And the function call is called COVID-19, and then it's just open the brackets, and there I've got some argument I'm using. So I name my argument first, and I put equal the value. I have been into the help, and they told me which are these values, and I had, played around with it, knowing that number 3 was going to be the one I needed. And verbose false, it should stop a lot of messages being displayed, such as the references, which I thought was not suitable for today. So that's what the function call look like. But what we have here as well, we've got this arrow, and that this arrow suggests, and all the results coming at the outcome of this computation will be saved in a variable called all.data. Now I'm going to execute it. And as you can see there, it takes a little while because it's going around the world, taking loads of data, and it's spinning and it's spinning and it's spinning. So by using this notebook, then as you can see, I can share some more explanations, and I can create as well an HTML file, then a report that can be exported as well as PDF. Oh, it's still going around the world, takes his time, and that's what it does. Have you got any questions while you
I do have one question from Irina. It's, could we get a copy of this code so we can try again later what we learned?
I would definitely will add it later on into the DataSHIELD R tutorial, and like this you will be able to use it, and I may actually zip perhaps the whole R project, and like this you can play around and even make improve it.
Yes,
but the people will have to basically install packages and the correct version of R. That's what I've noticed when I was preparing that.
Irina, we'll put a link to that our beginners course in the chat at the end.
Yeah. And we'll put that as well, a link from the workshop, our list of workshop, like this people can find all that. With Alex, we can do that for you. That would be fine. So the data is still being uploaded. So I'm going to go back to show you the next thing, and then we come back to that. So what will happen then? Oh, now that's finished. Excellent there. So I cannot see anything. So now what I will need to do, I will want to show the name of my columns. So I press what they call col names. It's a function, and they show me all my 37 row of data which I've got, which is being provided. And then what I've got, I want to have the dimensions of them. So let's have a look. And what is telling me that I've got 1,205,280 rows and 37 columns. So it's quite large data and quite consequent. So if we were to compare against Excel, Excel would be perhaps maybe able just to cope with that. I think the tutorial, we have some figures there, but that is just half of the size of a data frame in R. Yes, which for us was disappointing the other day when we were looking at that, because we need to work for our development something that is much larger than our data frame. So we'll have to tweak with the data and double them, triple them to do whatever we want to work with even larger data. Okay, so I've got my informations. Now I would like to make a subset of this data because it's so large, it will be quite cumbersome. So we're going to use what they call a data frame. It has some columns and some rows, and each column has a name. So I'm going to have a variable name, which is a vector, and it's called column names. And then I'm going to using, I thought I've seen date here. Yes, I've got date, I've got confirm, des. That's when I was looking at the data set documentation, they told me I could find some interesting information there. I've got this ISO alpha 3, that's the country, 3 characters to show the name of the country, some latitude and longitude, some stringency index, basically about lockdowns and how much people have been, protection have been put in place, the number of deaths and the confirms. So, so that's what basically I've been doing. And then I want to have my subset. So I've put the name of my data set, which is called all data. And then I put a comma because here will be the rows. There will be the rows. I'm going to delete that in a minute. That will be the rows, but I don't want the rows. I want to select my column name. So I put my comma and then column names, and all that will be selected, and copied in this new variable called all dataset subset. Okay, and then I want to print and show you the way it looks like. And I've got my last night version there. So, but we want to really execute the code and see what's going on. And that should be much faster. Took a blip of a second, usually it's faster. Then we could see, well, the USA appear first on that with some stringency index, which is between 0 and 100, and some number of deaths and confirm. Okay. But when I was looking at the data, I did find out some of them got some NA, non-numerical, and null values, which could create some issues within our data. So it's just a demonstration. And I thought, well, I'm going to select now all the value that's NA. So you have a function called isNA, and it's a logical one. It retrieves true or false. So I'm asking them, well, return all the rows where they got some NA values, and that, and then we've got a subset of these rows by putting in a square brackets. And as you can see, I do not have any comma because I only want to work on the rows on there. And then I put equal 0, and all this value will be replaced by zeros. Then I will do the same for isNull about my data set, and the same thing happen. I select all the rows where they got any null values in every columns, and then all this null value will be set to zeros. Then we're going to have a look how they look like, and we'll have a look to a graph. So when we want to do a graph, we've got what they call a plot. And this plot function, we have an X and a Y axis, and we're going to have like a little dot because there's so much data, otherwise it'll get very, very messy. So there are other libraries in R which would provide much more advanced tools, but I wanted just to use the basic R today. That's what it is. So we've got quite a few bits of data here, and we've got again that thing showing and doing the calculation. We have more than 1 million rows, so it can take a little while there. It takes a little while. And here that's basically our graph of confirmed cases and on the dates. So let's have a look back here. Here I said, show on the x-axis the dates and show the number of confirmed cases. And then it shows us for all the countries and all they are there. So Plot does offer quite a lot of tools to format your graph and to do that. Use the help, use online tutorials to do that. They show you that, and you've got even better libraries that will help you to format this data much better. But that's a lovely plot. I quite like that line in the middle that goes a bit like rises and then stabilizes, and then, you know, everything appears to be increasing from September, sadly, the number of cases. Sometimes we want to do some correlations. So we want to use, again, some scatter plot. So here we use, again, the function plot. And what I've done here, because I've got long names, I've got two variables. And for clarity for you, I've got the variable x, the variable y. And I wanted to have a scatter plot with the stringency index and the number of cases confirmed. I thought it would be quite nice to do. So I put my x and my y values first, and then I decided to have a title to this graph, which is something quite meaningful. And then I put some axis label, and they call X lab and Y lab. And I use the little dot again, because otherwise we can't see anything. And I decided I don't want any frame around it. And that's what my scatter graph look like. It takes quite a long time to redo it. I'm not going to do it. I just want to whiz through the example. But that's the way it looks like. And what I was looking at it, actually, it's for the data, you see, the more the stringency index increases, and the number of cases maybe increases as well. So there you go. There may be some relationships there. Perhaps the more cases we have, the more stringency we decide to do and implement. So there you go. But if I want to find some correlation between my two variables, I've got what a function called core, and it will give us the correlation index, which is 0.01, which is quite low. But when I've prepared last week, it was 0.06. So the additional values appear to have really lowered the correlation. So if I was going to do more correlation about the number of deaths and number of case confirms, I would repeat the same code again, but then my X value, as you could see, is called confirm, and now the Y value is the number of deaths. And the graph they show me, it's a different pictures there. Some element would occur, suggesting if I don't have many cases, I'm unlikely to have many people succumbing from the disease. And then as we increases, we've got some lovely lines there. Perhaps the treatments are being better cared for, and all this aspect must be lowering this curve there. But that's one observation. It might not be valid, needs to be validated by other research. But here we've got our correlation. That's more interesting for our purpose, and it's a 0.7. So there is some correlation between the number of case confirmed and fatalities, sadly. So that's really a basic use of R and how they're done, and what you can do with them. So we have explored the data, very large data sets. We have done some basic function calls, some correlations, and what can be done. Have you got any question before I show you a much more complex examples? Now we have warmed up a bit. Any questions, Alex, or anybody else?
I don't see any in the chat, but again, if you have any questions, do put them in the chat.
Yeah, or you can always email DataSHIELD, and we will respond to them, or use our forums. We're there to help you. We'll be delighted to help. Again, this second notebook will show more advanced technique of R. And it's not for epidemiology purposes is just to show you how data scientists can use R with some cleaning of data again and more advanced element to it. So please do not quote that for any epidemiology aspect of it or anything like this, please. We just want to work with large data. So we again using this COVID package, we're importing the data again. But what I wanted to do, I wanted to have a look at different countries, basically, which, to be honest with you, I took randomly. So I thought I quite like Malta, I quite like the United Kingdom, where some of us are residing in this call today. USA tend to be quite on the news, and then I thought Saudi Arabia, or part of Africa. So I went around and picked up some elements, and I changed my choice of country depending on what I was finding to illustrate the point and make it more interesting. Okay, that's what I've done. So I commented some codes here in front of you there, because what I've got here, I've caught myself doing over and over again the same code. So for example, for GBR, which was the free letter for this ISO code, alpha 3. I've typed on my COVID-19 function countries equal GBR. That changed the level because that level, the help informed me I would have like more summation of all the cases per day. And I put verbals because I didn't want to have all these messages coming every time I ran them. And then I thought, well, I need my columns names, but I want to save them. So I created another variable called GBR calls names. And I used the calls name function again. And the dimension, I reuse what I've done before, and I call GBR dim for dimension. And I've done the same for Malta with the MLT. So the name of my variables there are definitely hinting which country I'm going to work with. And as well, what the purpose is. One is for the data, one is for the column name, and one is for the dimension. In R, people are quite like working short names. So if it would be my preference, I would call like GBR called dimension. But people like shorter names, so I'm going to show the R way today. Okay. So what I did there, I created a function, and a function is basically some code, and you repeat over and over again, and for a purpose, and you create some arguments. So to do so, I put a name to my function, which called like upload data, which you can see here. I write the word function, which function is a keyword from R, that's why it's blue. And I said, I want an argument called country, and I'm going to set it to null, because if nobody puts any value, it's going to be set to null. Well, if somebody doesn't mention any countries, how can I search them? So what I'll have a look at it, I say, well, it has to be character. So this function that is character is checking that it's basically character. If it's a number, nothing else will happen. And because I've used the ISO alpha 3 and all this column, these values there are definitely 3 characters, and that's what the help told me. I thought, well, I put nchar, that's my number of characters, in the argument country, and if it's equal 3, that what will be, then I can do my search. Otherwise, nothing will be returned, nothing will happen. So this if statement says, if these 2 conditions are correct, are met, basically, so is character is true and nchar is true. If both are correct, the code below will be executed. Okay, so what I'm doing here, I'm going to create 3 names for my variables, the same as I had before, and it's called data, calls, and dims. Again, if I would be another context for my own code, it will be slightly longer, but R suggests and we have to write small names. So I wanted to demonstrate the way it could be done. Again, make it your own. And then what I use is an assign function, and this assign function will create the variable name basically the name of the country and data, which if it's GBR, it will be called gbr.data. And then it will call the function COVID-19, which is the country, which is exactly the same line as before, the level and verbose pause. And I say he pause 1, the position 1, it's the global environment. And I will repeat that all the time through it like this. I can control where my variables have been created. So that shows you how you can, if you repeat the code over and over again, you can create some function and use them again. And how is this code made available? It's made available in this line here, which was executed and made available as well in the other one. Although I didn't use it in the other one. So when we execute the notebook, all this code will be executed and this function will be created and made available. So now I've got these functions there, and for the purpose for you, I've made it as a comment like this. You can have a look at them, why they're there, and you know, and how they've been created. Then we make the function calls, and if it would be a normal notebook, all of this thing commented wouldn't be there. And all I have to do is create basically upload data GBR, and I've got Malta, the Great Britain, Saudi Arabia, New Zealand, and USA. So quite different countries from what we've seen in the news. And then I want to have a look for whether or not my variables have been really created. So I put ls pos is equal 1. The ls will list all the variables. The position is the global environment. And that's what's been returned, all this variable. And if you can see here, I've got what they call like GBR dims, GBR MLT calls names, MLT subset, and other element. Actually, I'm going to execute all this code because they're the old one, and that should not be, and I'm going to execute them now. That should be faster, hopefully. Right, while it's update, we can move on. And then we're going to explore the data again, and I want to have a look at my dimension, and we're going to print them. So there they gave me some console for the way they look at the console, but because I've got some functions such as class, they will come in our console. But if I've got like the head of each data, they would create their own little view. So I can have a look there. And if I double click on it, below, I can see the head, the 6th first row of each data set. Oh, and you can see that I've got loads of NA because at the time there, they probably didn't have any cases, which make my life as a data scientist quite a bit annoying because I won't be able to process the data. So then I can create again my subset of data. We had a look previously how it was done. And what I did, I created again another function, which is shown above, because I didn't want to retype this line all over again. It was getting messy. It was always the same code. It was easier to use it. So I've clicked, and then what we've done, we clean our data set again in the same way we've done before. And what we've done here, we have removed the non-numerical value and the null. So you may be asking yourself, why didn't you use a function? I should have used a function, but I thought you're such good people. Once you've got access to the code, I'll let you write your own function, reuse the code, and see how good you really are at it once you've done the tutorial. So feel free to create that and create the functions there. So let's have a look at some scatter plot for each countries. And there you will see the plot got loads more variable and arguments to it. So I thought I'm going to print first a summary of my data. Look, summary function give us the information about the distribution of each subset of data. and then it will going to show a visual representation of the data. Often, whether we use MATLAB, SPSS, or other packages, that's what we tend to do. And in my plot, I've added different points. I've used the PCH4, the type P. I can't remember what the type P was in the help, which I think it was just some points there, some different colors, some dates, and some titles. And I created a plot for the number of deaths and the number of confirmed cases through the dates. So the result in my consoles gave me the summary, and the summary in R, it's quite detailed, and it gives you some parametric and non-parametric statistical measurements, and you can have quite a quick glance of what is happening with the data. What is interesting with the population, it is never changes. So I mean, it is based on the world population data, I think, and it never changes. So the number of deaths are not decreased there. So with the calculation I'm likely to do might not be accurate, but everybody using that. And that's what my graph looks like for the confirmed cases. I've got the dates here, the number of cases, and you can see sadly how they are increasing or not. So that graph was indicating that the COVID-19 package is a accumulation going through day by day. And for the number of fatalities, sadly, the number increases as well, and it's cumulative as well. So we've done that for each country. I've got here, should have done that for each country. I'm going to execute the whole thing, and we'll have a look at our pretty graphs. There you go. Oh, and I've got an error here. That's bad, that. So I will need to do something about it. Sorry. So we should have a graph for each of them, and show the differences there. Ooh, there you go. I've got Saudi Arabia there. I thought when I looked at Malta, they had issues with the data. But before I share the notebook with you and our project, I will definitely look at that and see what is going on. And then you can see as well how the curve they are moving along. Good. Now, if we want to do some more complex data manipulation with our structure, we can do that. And I decided to compute the rate of change because they are accumulative. So I wanted to know per date how many cases they wanted. So to do that, I could have used the loop, but that would have been quite challenging. Instead, what we did, we use functions calling other functions. So I'm going to explain to you how that works. We've got what they call something called apply. And they got a string and a family of function called apply, like v apply, s apply, t apply, and and they all work on the same principle. They will take all the values or the values provided by the data, and then they will apply a function to it, which is the diff function. And the value of each contained will be passed as the first argument of the function diff. So the function diff will calculate differences between two rows of two values. So here it will take the value of the current row and use the previous value of the previous column. If for previous row, if you set apply at 2, it will get the differences. It will use two values, one from the row before and the current row, and then it will pass them as the diff function, and it would create then a new data structure. This new data structure I thought was a data table, but we really wanted it as a data frame. So I'm suggested it, you format that as a data frame, and now I can work it as a data frame. Then based on that, because there were still units, I thought, well, what I could do that as a percentage or as a ratio per the population. So I looked at the function rate of changes of the column deaths, and look at the notation I have used. I was forced to use that one as the name of the column between quotes, and then I use all the data, the populations from the other data set data, and I use all the rows, which is 1 to number of rows, because the rate of changes has 1 row less, and that will not work. And then we divide by the population, and then we'll have basically our percentages of our rates. And that happened for the fatalities, recovered and confirmed case. And I wanted to return that result here. So this line here will return that new data frame we created. This function is again in the tools.r. I just put it there for simplicity at the delivery of this tutorial. So there you go. I compute all my rate of change here for all my data for my 5 countries. And then let's have a look what's happening now. I'll run the whole thing again. And then we're going to have a look at these summaries and some graphs, how they look like. But that's to demonstrate, and you can do some quite nice manipulation on this structured. Ooh, excellent. And here I've got, which country was that? Oh, I'm just plotting the summary for the United Kingdom at the present time, and they tell me again this summary. So that's the rate of changes there. That's what would happen from one day to another one. And then they give me how the rate of changes, a bit like calculus, how basically they're increasing, staying stable, or decreasing. And according to that, I've run it last night. You can see, well, it's supposing to be decreasing by the number of the populations. Right, so I can run that. So let's run all this summary, shall we? And these graphs, and then we'll have a look at one graphs and see what they look like again. So what we do in R, it's all function calls, and you can write clean code. I mean, you can understand if you spend time to have a look at it by writing code like this, you know, between code, putting meaningful names of your columns, of your elements, and writing nice graphs. What it's not when you use notebooks is you can put more explanations. And if you have to make a report for somebody, you can create an HTML file or a PDF. So now I wanted to compare all this data using a box plot, because I haven't demonstrated that to you. And I compared the box plot with this rate of changes of number of deaths per day there. And as you can see, that New Zealand, it's much smaller from what we've seen from the news. That matches it. Saudi Arabia, it's much more compact, and USA, United Kingdom is another story. But having said that, Malta would have quite a few outliers of increase and decrease quite rapidly. Hence, we've got this graph. So that's the way basically R can be used to do some data analysis, manipulate some data structure data and uploading some data. So now I need to find for you what we call our beginner's tutorial, where you can find it. So let's have a look. Let's find it. I need to go in my browser, and then we'll be finished. Right. So to find it, you need to go on our DataSHIELD website. and it's datashield.ac.uk. Then you go into what they call the wiki. Oh, and it's me doing, and Stuart doing the demonstration. And Alex done a fantastic job with Elaine to structure differently our, make it more user-friendly. So you can find fantastic resources there, and they're working so hard at it. And here, what you will find here, it's a link to this workshop here later on. But what you're more interested in is the R statistical introduction tutorial. And what you will find, it will introduce for you the tutorial where you can find information, the reading list, the comparison to the spreadsheets and all these elements, what you want to know, how to install. It's making you as well familiarize with the RStudio interfaces and how you can make it work to yourself and all that, and you'll have some practices as well. Okay, so some of the code here you cannot copy and paste because I'm assuming we all do copy and paste it, but when we start a programming language, typing helps. Okay, so you will have some practice exercises as well as some additional reading list, and how to create a script. And a new version, what we've done just for you, it's to do the R notebook and how you can do them. So there you go. We have some in there. There you go, the R notebooks. And I've got some R Markdown tutorial, how to do the formatting and how to create them. Now we've got some data structures as well. The vectors, everything is a vector in R. In MATLAB, everything is a matrix. In SPSS, I'm not sure. But so basically, you will be working and manipulating them. As well, some elements how to communicate with R and making your elements, your data science, your script or your models a bit clearer. And finally, something about R function, things I really brushed it, but how you can create them and learn how to do them. So to complete, Alex, did you want me to show this page as well? Did you want to add something?
Yes, thank you. So in a week's time, hopefully quite a few of you have already signed up to attend the December DataSHIELD Beginners Workshop, where we're going to spend 2 hours taking what we've learned here with Patricia about R and then learning how to use functions in DataSHIELD for privacy preserving analysis. So yes, I'm about to put the link to this page in the chat. If you haven't yet signed up to it and would like to, do email us datashield@newcastle.ac.uk.
So have you got any questions?
There is one question from Benedict. He says, is it possible to run multiple graphs with a function?
Yes, you can. If you look, I'm afraid if you, there are a possibility to do so. They tend to be quite small. So only use the base package of R, which is, it's okay, but not quite brilliant to get some graphs so done. But there is some additional packages that can be used to create much better graphs, much better visualization tools there. That can be used. So what I will do with that, I may add a page, but I'll do that before Christmas because we're quite busy at the present time, and add some packages that can be used to do graphs and all this element with that so that people can use better libraries. How does it sound, Benedict?
Thank you so much for your presentation and for your answer. Yes, it's a very good idea. Are you talking about ggplot and ggplot2 when you say packages?
Yes, that is the one. That's the one that skipped my. That's the one I couldn't remember then. That's why. But to be honest with you, personally, I rarely use ggplot. My colleague Hugh Garner use it all the time, and he's really the visualization specialist of our team. So he's the one, but ggplot, that's the one to use, definitely.
Okay.
Yes. Yeah.
Yeah, I would say just when I was thinking about functions, I'm struggling with when you want to put the titles. I guess it is easy maybe to make a function for creating graphs, multiple graphs, if you don't have to put titles which should be different, like if you want to add the names of the countries and so on.
Yes, that would be fine. Hang on, I'm trying to find my RStudio again. It disappeared annoyingly. So when you write the name of your functions, every argument, basically, the way I tend to do that, I tend to have one example. I know it's working, but I want to repeat it. So my function becomes with no argument at all. And then I do one argument at a time and test the function. And the title could be definitely as well added to it and wrap ggplot or do this type of element. Definitely, yes. If you need some help, please email us and I will help you with that.
Oh, that's very nice. Thank you.
You're welcome, Benedict. So I hope you did find it useful. I was trying to do more as a statistic element to it. And I hope the tutorial will help you adapting from your knowledge of statistics. And if, as well in a tutorial, we added links of some free book, PDF book about advanced statistical methodologies, just in case you wanted to use them in R, but not quite sure about how to use them. So if you're watching this video and not sure how to use some statistics, go into the tutorial and use that book. But I'm sure our audience know all of them better than the presenter. So anyway,